All right, hey guys, we're going to do section 4 today on equations with variables on both sides. Basically what we're going to do is we're going to follow the same steps except for we have one extra thing we need to do first. So I'm going to kind of write in this area right here, but just to kind of go over the steps with you. So the first thing that we want to do is simplify each side of the equation. So simplify each side of the equation, and we'll take a look at what that means in just a second. But basically what you want to do is use the distributive property, combine like terms on each side of the equal sign. The second thing we want to do is we want to use the addition or subtraction property of equality to get the variables to one side of the equation. So after we simplify each side, we want to use the addition or subtraction property of equality to get variables to one side of the equation. And then the third thing that we want to do is just follow our steps that we've done before. We want to solve for the variable. So let's take a look at some examples of this. So if you look at this first example, A, you're going to notice you have negative 6d equals d plus 4. And what I'm going to do first is just kind of ask myself, is there anything on each side of the equal sign that can be simplified? And when I look here, there's not. There's nothing that can be done on either side. There's no distributive property. There's no like terms to be combined on each side of the equal sign. So then the second thing I want to do is get my variables to one side. So if you notice, I have this term with a variable and I have that term with a variable. And so what I want to do here is I want to move one of them to one side. And since the negative 6d is the only term on that side, what I'm going to do is move this d over there. And remember, if it's just d, it's like saying 1d. So I'm going to subtract 1d on both sides of the equation. This one's going to cross out because it's equal to 0. So now I have negative 6d minus 1d. That equals negative 7d. And what I have left on that side is my 4. And then now I'm just down to my one-step equation. To get d by itself, I'm going to divide by negative 7 on both sides. So d is equal to negative 4/7. Okay. I'm actually going to go down to this example right here, right below it, because it's very similar to that one. I'm going to ask myself, is there anything that can be simplified on each side? Over here there's not. Over here there's not. So what I'm going to do now is move my variables to one side of the equation. So I have an m there and I have a 3m here. And if you notice, this 3m is the only term on this side. So I'm actually going to move this 1m over there. And to move it, this is a positive 1m. So I'm going to subtract 1m on both sides. Some people get confused because of this right here. They want to they want to add 1 because it's a subtraction sign there, but this 1 right here is a positive 1, which is why I'm going to subtract. Remember, this negative sign belongs to the 5, so this is actually negative 5 is equal to 2m. And so now I have this one-step equation. I'm going to divide by 2 on both sides, and what I will end up getting is m is equal to negative 5/2, or negative 2 1/2. Okay. So let's go back up to the top right example, and this is an example of where we actually have to do some simplifying first. You can see on this side right here I have the distributive property that I need to do. So that's where I'm going to start. I'm going to do 2 times c, which is 2c, and then 2 times negative 6 is a negative 12, equals 9c plus 2. Now, if I look at both sides, they are simplified, and so now I'm going to look at my variables. This is what I have. It doesn't matter if you subtract the 9c and move it over to the 2c, or if you subtract the 2c over to the 9c. I like to try to keep my variables positive. So what I'm going to do is I'm going to subtract this 2c, because remember this is a positive 2c here, so to get rid of it I need to subtract it. I'm going to subtract that from the 9c because remember we can only combine like terms. This crosses out, so now I have negative 12 is equal to 7c plus 2. And so now I have here a two-step equation. So remember we have to undo our addition or subtraction first. So I'm going to subtract 2. Negative 12 minus 2 is negative 14 equals 7c. And then now I'm going to divide by my 7 to get c is equal to negative 2. Okay, and if I substitute that back in there, it should work out so that each side is equal to one another. So negative 2, so if I was to do this just to kind of show you, negative 2 minus 6 equals 9 times negative 2 plus 2. Well, this is negative 8. 2 times negative 8, which is equal to negative 16. And over here, this is negative 18 plus 2, which also equals negative 16. So this right here is just an example of how you can check it to make sure that your answer makes sense. If I look at this next example, if I look at each side, there's nothing I can do. There's no like terms on this side that I can combine. There's no like terms on this side I can combine. There is no distributive property. So my first thing I'm going to do is look to see where my variables are. And I have this 7k and I have this 5k. Now, as I mentioned before, I like to keep my variables positive. So if I subtract a 5k on this side, because remember, we want to make it equal 0, and I subtract 5k on this side, 7k minus 5k is 2k. I still have this minus 4 equals a positive 16. I could have, and I'll show you in just a second, I could have subtracted 7k on both sides, and that still would have, I'm still going to get the same answer. But I'm going to add 4, just to kind of finish this up. I'm running out of room. So 2k is equal to 20. Divide by 2, so k is equal to 10. And I'm going to steal kind of the top part of this page right here. If I go back to the original problem here, whoops, and let's just say I subtract 7k from both sides. If I just do the opposite, now I have negative 4, because remember this negative sign belongs with it, equals negative 2k plus 16. I'm going to subtract 16 on both sides. Negative 4 minus 16 is negative 20 equals negative 2k, and then I would divide by negative 2 to get k equals 10. So did I get the same answer? Yes. So it doesn't matter which way you move your variable. You can either, like I said, I always like to try to keep it positive if I can, but it doesn't really matter. So here's an example. It says, a hairdresser is considering ordering a certain shampoo. Company A charges $4 per 8-ounce bottle plus a $10 handling fee per order. Company B charges $3 per 8-ounce bottle and a $25 handling fee per order. How many bottles must the hairdresser buy to justify using Company B? So, a couple things here. Company A, it's $4 per bottle and a $10 handling fee. Okay. Company B is $3 per bottle and a $25 handling fee. So if you notice, it's cheaper per bottle for Company B, but the handling fee is more. So basically what we want to do is find the break-even point here. We want to know when it's going to be the same. And so then that way we can figure out when is it going to be better to use Company B. I'm going to let B represent the number of bottles. So what I'm going to do is take Company A, and I'm going to take 4B plus this $10 handling fee. So this is for Company A. And then for Company B, it's $3 per bottle plus a $25 handling fee. And I want to know when are those going to be equal, because this is going to tell me when it's going to be cheaper to go with Company B. So again, we're just going to solve this. Let me get my highlighter. I have 4b, 3b. If I look at this, there's nothing to simplify on each side. I'm going to start by subtracting 3b on both sides. So this is equal to b, or 1b, plus 10 equals 25. And then I'm going to subtract my 10 on both sides to get b is equal to 15. What this tells me is that at 15 bottles, the cost is going to be the same. So if I order more than or greater than 15 bottles, that is when company B is going to be cheaper. Okay? If I order 14 bottles or less, so if I order less than 15 bottles, you want to go with A. If it's greater than, you want to go with B. And if you're going to order 15 bottles, it doesn't matter, A or B, because they're going to cost the same. I hope that kind of makes sense. And then the last thing for this section is talking about identities and equations with no solution. There's going to be times when you don't get, if you go through solving these, you might not get your variable equals a number because it could be an identity or it could be no solution. So an identity is basically when you can put in any value, every value, and it's going to make the equation true. Okay? So it's an equation that is true for every value of the variable. So an equation that is true for any value of the variable. What that means is I could put 5 in, I could put 10 in, I could put negative 100 in, and both sides are going to be the same. If it has no solution, no solution is if there's no value that you can put in. So an equation that has no value that you can put into it. Okay? So if I look at this first example here, and I'm just going to kind of copy it down. 9 plus 5n equals 5n minus 1. So if I go through and try to solve this, there's nothing that, whoops. There's nothing that I need to simplify on either side, so I'm just going to start by moving my variable. And if you notice, I'm going to subtract 5n and subtract 5n. Well, 5n minus 5n is equal to 0. 5n minus 5n is equal to 0. So what I'm left with here is 9 equals negative 1. Is that a true statement? No, 9 does not equal negative 1. So in this case, it is a no solution. There's nothing that I can put into this equation that's going to make it true. Okay? Now if I look at B, 9 plus 5x equals 7x plus 9 minus 2x. So this is an example where I can actually simplify a little bit on one of these sides. Over here, there's nothing I can simplify, but over here, there's actually two terms here that are considered like. Okay? So I need to combine those first. So it's going to be 9 plus 5x is equal to, well, 5 minus 2 is 5x plus 9. And some of you can already see here that both of these sides are equal to one another. It's the commutative property that makes them equal. But if I just kind of go through, if I subtract 5x on both sides, now I have 9 is equal to 9. Well, does 9 equal 9? Yes. And so this is an identity. It doesn't matter what number I put in for x. Each side is always going to be true. Okay? So, the big thing to remember is, whoops, I just went by it. Simplify each side of the equation first by doing the distributive property, combining like terms, okay? And then get your variables to one side, and then you want to solve for the variable, doing what we have been doing in the past. Have a great night, and I'll see you guys tomorrow.